The broadcast is now starting. All attendees are in listen-only mode.
This webinar. My name is Matthias Robertson. I'm your host. We will record this webinar so you can share it and view it later at any point. I'm based in Sweden. See if we can get a webcam going here. Maybe. Yep, starting up. Shut it down. I hope you can hear me. This is the most important. We will be a little bit interactive. So could you please use the poll to see if we can have audio or not? I seem to have a good response. Thank you for that. You can use the chat to ask questions. We'll have a Q&A session at the end of this webinar. So feel free to ask any questions. We will be a little bit more interactive as well. We can do the next question just before we get started. So I'm a bit curious to know what SolidWorks version are you using? Just to get an idea of what versions you are on, or maybe not have SolidWorks or don't know what version you're on. Just give me a feedback. So it seems to be about 40% on 2018. That's good. And many on 2017 and 16. So thank you for that. Okay, let's get started. So we will talk about design for manufacturing today. And throughout the years, we have really developed new technology. So the whole product development process could be changed and improved. And I think this is a thing you should constantly do to review and look at your development process. Because there are so many good things now, good technology we can do to speed up the whole process. Starting from conceptual design, starting to make models and optimize the models using simulation very early. And in 2018, we have this topology optimization, really nice technology to make an optimized shape. Now today we will talk about the next step, and that is just before releasing a product, there's a number of checks we can do to make sure we have a good product that is easy to manufacture. So we will check our design for manufacturability and fix any problems that might be costly. I will talk a little bit more about this, why this is important and what's the benefit here. Now, most companies are doing 2D drawings. That has been our legal document for 100 years. But there is a new technology that is emerging, and that is model-based definition. And that is a standard that we put our manufacturing tolerances directly on the 3D model and send that 3D model with the tolerances directly to the CAM operators. So the CSE toolpath is directly on the SolidWorks model reading our tolerances. So it's no need for 2D drawings. We do a model-based definition documentation with a 3D PDF and include the 3D model there with every information needed. This is a very good process, very fast and very accurate. Now, tolerances are important, and we can do with SolidWorks inspection some documentation to capture and document your quality reports from the manufactured parts. Now, of course, we have other tools for documentation, like SolidWorks Composer or other ways to document, make instructions. And of course, with photo view or visualize, make some really nice product presentation and animations and have a finished product with all the documentation here. So this is a view of the design process. And we will talk more about check your design for manufacturability. So why do we need this? Why is DFM, as we said, important? Well, first of all, the purpose is to make design that is less costly, and you will get a better quality product faster. Because in some cases, I've been visiting some companies throughout the years. You're sitting and designing the part, and then you just throw it to manufacturing overall, and the guy who's going to produce it is getting angry because there's a lot of things you didn't think about, or makes this guy's life work harder. I'm exaggerating, of course, but in some cases, this is taking a lot of resources. So we want to catch and fix the problems early in your design process, in the design phase, when it's cheaper, and don't get a nasty feedback from the manufacturing. Well, why do you do this? Why haven't you thought about that, and so on? So it's all about improving communication, and think of the next step in the process. If this is going to be manufacturing, have I done all I can to make it a good quality and easy to manufacture? And these are a couple of checks we can do, and I'll go through them, some tips and tricks, and some new products, new technology we also have in this area. So we want to capture your best practices, your best manufacturing practices, and have a good process there. So let's get started. So what process are we talking about here? Are we milling and drilling, turning, casting? Do we have sheet metal, injection molding, or additive manufacturing? This is 3D printing. And I will go through some areas with some tips and tricks, what to think about here. So let's get started. First of all, the most commonly used, I will say, or the reason when I was started with 3D CAD was to do the interference detection with 3D models. This is coming from 2D to 3D. This is the most common way to check your parts and see a value of 3D collisions here. Now, the interference detection have a lot of settings, so I would like to suggest you review and understand all the settings, because we can do quite a lot here with different settings here. One classic thing throughout the years have been fasteners. Since many releases ago, we could check fasteners for collision. By standard, the thread is colliding, but we treat thread collisions in the interference detection by some settings. And what it will do, it will actually check your thread here. So on the right hand side, we have a video here. We can see that it is colliding by the check. And by changing the length of this fastener, you will see that there's no collision anymore. So it really checks the matching thread on the two components, and also the length of this thread. So the fasteners is perfect there. That is quite good to know if you have some fasteners in there. There's also another check that is quite nice to have to do, and that is called the hole alignment. It's under evaluate, and it's for assemblies. And so here it goes. So you press hole alignment, you set a tolerance of holes, and it checks holes on different components and see if the center of the holes is are not perfect. And then it will get a report of some off-center deviations here. And this might not be a problem, but it's a good check to do just to make sure you have some good tolerances and have better quality product there at the end. Another thing we can do is clearance verification. This could be different parts. So we have a space. On the left-hand side here, we have a hatch that will open, and this pipe is definitely too near here. So it's kind of looking for the space in between components. And that it is a static check. We can do a dynamic check, and this is under move components in assemblies. So check for dynamics clearance, and then press two objects and set a tolerance, and then you have a minimum dynamic setting here for the minimum distance between the objects. It could be quite good for positioning and having more freedom and understanding the minimum distance between components there. Another assembly check we can do is to understand the impact and the importance of tolerances. If you're using SOLIDWORKS Professional or Premium, you have tolerance analyzers stack up. And this comes from the manufacturing tolerances we have on with the DFMXpert. And it put things together. So it's a wizard you go through. And the end result is that you're looking for quality output. And then you get here on the lower left-hand side result of the impact of the tolerances. Because some tolerances might have a bigger impact, some other tolerances have a smaller impact. And it's a really good understanding tool to understand how tolerances are important for the total outcome here. And it doesn't work to set everything to maximum, everything to minimum. So it's really playing out in the worst case scenario to get a realistic result there. So it's really good there. Another thing for if you're having molded or casted parts or designs is to do a draft check. Now, if you have a plastic designer or a casting, you need to understand the draft angles and where you have draft angles and where you have not, or maybe where you need some draft angles. And also to do an undercut check. And this is if you want to have a tool with two parts and an undercut tells you it's stuck. You cannot do it with two parts. Otherwise, you need to modify the geometry, or you will end up with some more expensive tool like doing more cores, more moving parts, and so on. So it's a good check to see that you have not run into some more costly area to fix this as a tool. Another thing that is quite important to check is for the thickness. If you are doing casted design, or especially for injection molding, where even thickness is super important for a good design, there's a quick check you can do for checking the thickness in the model there. And also we have some geometric checks. If you have some important parts or some parts with a lot of small faces, we have this geometric analysis to really understand how and where small faces are located. Some CAM programs could run into a problem here, so maybe you can delete some faces and smooth things out. So it's a good tool to understand if you have some small areas in the models or some gaps. So let's talk a little bit more about injection molding. We have a good tools and some very good checks we can do for a part on a part level. And as a designer, if you're designing plastic parts, this tool will help you to give you some answers if and how the part will fill. Will it be in a weld lines? Will it be in air traps? So we can simulate the molding stage here, the filling stage. And this is called SOLIDWORKS plastic standards for designers. So gate location, if you look here on the movie, it's all about where you're putting the gate, or should we have several gates where the plastic is entering the mold cavity. It will have some effect. You can end up with weld lines, you can end up with air traps, but also you need to understand the flow front, because you can have a phenomenon called race tracking. We'll talk a little bit more about that in a moment. So the first and important thing is the gate location. Why is a gate location important? Well, it gives you the flow directions in the part. And if you are reinforcing your part with glass fibers, for instance, in this case, you will stretch the fiber in the flow direction. So you will have a much weaker part across the fibers, but you have very strong along the fibers. And here we can see how it will crack if there is some break or failure here. Now we can use this in advantage. If you look here in a clip tie, how they are manufacturing, and that's the purpose to put the gate here on the end, because now we have the fiber along the length and it's super strong along the length. but it's weak across it. So if you make a rip here, you can rip it apart, but it's super strong along the length. So really understand gate location for manufacturing purposes there. Short shots, if you make thinner and thinner parts, which is the trend in many industries, you could end up in a situation where the plastic will solidify before it fills the whole cavity. And it's important to understand that if and how you can fill a thin part. Race tracking, if you have variable thickness in the part, you will have different speed of the filling process. The bigger cavity, it easier will flow, and this is something called race tracking. So if you have the gate here on the end, if you look at the movie here, we can see the flow front going much faster in this area here. And we can go back and forward and really understand where the flow front is behaving here. So here we have some race tracking. We will have an air trap here. And we can see the flow front and how it's behaving. And the trick is to have a more uniform flow front. So if we change the size here, then suddenly we have a much better uniform flow front in the filling process. So definitely for plastic parts, we really need to think about manufacturability to make a good design here. Just to finalize here, if you're opening up some plastic parts and you look inside, and maybe you can see some ribs, you might think that, yeah, that's for reinforcement of the part. It will be stronger. Yes, it will. But maybe the ribs are only there for manufacturing purposes. So if you have a gate here in this center, the end will fill up slower. And as I said, we want to have a uniform flow front. So there's a trick to add a little rib, a little more geometry here, so make it a little bit easier to flow. So we will end up with a flow front that is uniform also in the edges there. Just a little tips and tricks how we can make things better for the injection molding process. Now this falls for the plastic part designer. We also have SOLIDWORKS Plastic Professional and Premium, and these are for mold makers. I will not go into detail how that works, but just to give an idea of more areas we can test and check our mold tools for manufacturing purposes. Anything from warp, runner balancing, venting analysis, and yeah, a lot of checks we can do there for the mold tool. So this is Plastic Professional. Now, jumping back to SOLIDWORKS, we have a tool called DFMXpress, and this is included in all SOLIDWORKS licenses. And I will go through how it works. And this is something you can check. Is under Evaluate, and then you go to DFM Analysis Wizard, or you can go to Tools, Express, and DFMXpress. Now, if you have never used this tool, all our Express products requires an activation, and you do it by go to mysolidworks.com. You can create an account there. You can go to mysolidworks.com even if you don't have SOLIDWORKS to create an account, but this is a portal that we want to gather more information, where you can get the information and yeah, have a good resource for SOLIDWORKS information there. So this is how we activate the product. Now, what does it do? Well, it's an add-in. It will have some settings about different operations, different processes for mill and drill, turn with mill and drill, sheet metal, or injection molding. And then you have some parameters to adjust. Now, so selecting the process and the parameters, it's no template, it is just some values that you will enter. And this is the Express product. It comes, is an entry level, it's a little brother to the full-blown product. I will talk about that in a second. But what does it do? How does it work? Well, you press run and it will recognize the features, look at the geometry, look at what process and the parameters you have set, and you will get a result quite quickly on some best practices, on some rules. Now, green is good, that is check, and some failures here. And here it is complaining about, you have put some fillet outside, It's not a failure in that sense that it cannot be done, but should we have an outside radius, it will be more expensive because we will need more toolpath to accomplish this. And if we had just selected a chamfer instead, it will be done in one go. So it's a rule to check for outside radius because that is more complex way of manufacturing this part. It can be done, but more costly. And this is a tool to check for that, for instance. Now, I want to highlight this bigger product. It's called DFM Professional for SOLIDWORKS, and it's a partner product. It's not from SOLIDWORKS, it's a solution partner. And this is more full-blown capabilities of supplier capabilities, your competence, your best practice. So you set up your rules in a knowledge database and apply them to your models and get some reports from that. And there are some lot of checks depending on what kind of process, manufacturing process you are using for producing your parts here. And there's some examples. So it looks exactly the same. It is totally integrated. It has more settings and templates and database, and you can record and store your best practices on how to design certain parts for best manufacturing capabilities. And then you have different reports and output from that. So DFMXpress included in all SOLIDWORKS licenses. It's an entry level that you can do basic checks. So if you are using mill and drill, turning, injection molding, sheet metal, please try it out. It is included. No reason not to use it. And if you're interested in this, contact your local reseller for more information, because there is an add-in called DFM Professional where you can do much more of this. There's also more information on SOLIDWORKS website and on their portal there. Now, I will make a new product announcement. It was announced at SOLIDWORKS World. We have a new add-on for SOLIDWORKS called 3D Expert. It's a plugin for 3D printing or additive manufacturing. So it's free. If you have SOLIDWORKS on active subscription, you can go to 3dsystem.com on their website and look for 3D Expert for SOLIDWORKS. You can download it and you're ready to go. You will activate it through mysolidworks.com and some other steps there, but pretty fast to get started. And so if you have an active subscription and are interested in 3D printing, you should definitely have a look at this. It comes in different flavors. There are some add-ons that they can purchase in different levels. So contact your local resellers on that information. And what it does is you have your design in SOLIDWORKS and you want to print it. And there's a gap here because we need to think about the 3D printing process. And here where 3D Expert comes in place. So you take the SOLIDWORKS model and then you position it. You can optimize the structure, create supports, and arrange the print, and then you send it to the printer. So when I saw this the first time, I didn't realize how important it is to prepare your part for 3D printing. So it's a standalone application, but I'll show you how it works. There's some images how to create the support. And also the structure. Do we have a solid structure? Maybe we want to speed things up or make it lighter to save material or make it lighter. So there's a lattice settings, a lot of settings how you can modify the mesh internally to make it better for 3D printing. See how it works. So we are in SOLIDWORKS. And then we just press 3D Expert for SOLIDWORKS and it moves over. Now it uses the 3D geometry. It's no mesh needed. It uses the solid and then you're into the 3D Expert for SOLIDWORKS. Then the first thing we need to do is to understand the positioning here, where to position it. There are different strategies that is good. Maybe some need some more support, less support, printing time. So you need to decide what is the best strategy for there. And then we place it. Now, we're going to need some support underneath here. It's floating in the air. It's kind of very organic shape here. So we go into the support manager, and then we can see how different supports are needed on the faces there. Lots of, I think we have 35 different support types with different settings. You can say this is templates, and just to create some nice support there for the model. Some other things we can do just to have a look at this part and divide it into different sections. And we want to do this lattice in different areas of the part. So basically we're cutting the part in different zones, and we're going to end up with some settings here on this zone with this lattice parameters. So this is the internal mesh we can do to make things lighter or modify the structure, internal structure of the 3D printed part. So we don't need to fill it up as a solid. It will take longer time and maybe not necessary for this prototype or this application. Now, this is good for metal printing or for polymers parts. And as I said, it comes in different flavors. This is the professional version that is full blown. So more information, contact your local reseller there. So additive manufacturing is really helpful for complex shapes, lightweight, and you can have a lot of settings on the surface textures for medical purposes and so on. So quite a lot of things happening in this area. Now, I also want to mention SOLIDWORKS costing. That could be a tool before you are sending or approving your part for manufacturing to get an idea of your part. How much will it cost to manufacture? Now, you need to put in some values here and have contact with your local suppliers to get more accurate. But it is a good tool to understand if a design change will be more costly than other. Will you save some money due to the operations depending on the geometry? And this comes with all SOLIDWORKS Professional and SOLIDWORKS Premium. So have a look at it. And sheet metal is really good for this costing estimation here. We also want to mention again SOLIDWORKS CAM, that is also included in SOLIDWORKS licenses with an active subscription. So you can create the CNC toolpath directly in your SOLIDWORKS model. Now we have almost come to the end, so I will just launch my final poll here before we make a summary and take questions. So if you want to have more information or demonstration or price information, participate in the workshop or no feedback, that's fine. You can select multiple choices here as well. So I will leave it running for a little bit longer. So please give us our feedback if you want some more information on some areas. We have covered a lot of information today. I know that. So, and we will share this link to the recording so you can view it again, show it to colleagues, see what it's all about, and contact your local reseller. That is your first line of contact there. All right, we will move on. So you just leave it a few more seconds to get your feedback on this. And thank you very much. And let's make a summary. So this whole idea of design for manufacturing is to help you reduce cost and make better quality products faster, save time in the whole manufacturing process. This idea to catch and fix problems early in the design chains, very cheap. You make quite big decisions on material, manufacturing process, your geometry, your tolerances. So think about the next step. How is it easy to manufacturing this part so you can get it as soon as possible? So we want to really establish a communication between design and the manufacturing area. And capture and make use of the best practices within your company. And yeah, that's basically it for me. We have 1 minute before 30 minutes, so I will thank you for participating, and we will see if there are any questions. I will stop the recording now. So thank you for listening in.